here to talk through this Thermo-Sudoku, the X box. It has an interesting intersection of thermometers in these four cells, which will end up having a interplay where we have sort of low numbers coming into middle range numbers and getting to very large numbers. One of the first good observations to make at the start is just the limits in size of the digits in these cells. Because of, on the lower end, two streams coming together in each case, as we see here, this digit can't be as small as a 3. Normally you'd have like a 1, 2, 3 option, but when you have a second thermometer coming in, if this is as low as a 1, the cell above is as low as a 2, as low as a 3, this is as small as a 4. So you can actually place a boundary, and I'm just drawing this sort of shape to represent these intersections. A 4 on the low end, and because there are 2 more on the other stream going out, 7 is the limit on the high end. And so in spots like this, you could write 4, 5, 7, or 4, 6, 7, or in this case, 5, 6, 7, and use that to get going. If you place those notations in the grid, what you'll recognize is the first spot you'll make any progress is really this box on the right side, in part because the thermometer numbers exiting these junctions will be 5 or higher. There are already 2 numbers 5 or higher in the space and 3 to go, so these are all very large digits, the smallest possible, and these cells is 6 and 8. 6 and 8, this is a pair, and we get a first sure placement in the puzzle. You might just randomly choose to search around the grid for the next spot, but if this is a hard digit to find, the natural place it most influences is this other extreme, which used to be as large potentially as 9. Now it's 8 or smaller, and that constraint you can already see from a cell like this, where we used to think this could be as large as a 7. Well, that's just not going to be true. The key place to actually work from this 8 or smaller is if this is an 8, and I guess I might as well just write in 6, 7, 8, which right now is the limit of what we know for the cell. The number 1 off of this, 8 can come down, but there's already a 7 in the spot, so it can only come down to be a 6 or a 5. Remember, this has to be 4 or larger, so you can't have any number smaller than 5 in that cell. That now gives us just 2 choices for this. Remember, it has to be 4 or larger, and it has to be smaller than these, so it continues in this direction. Let's just go to the next cell in this thermometer group. 4 is the largest it can be. It can be a 3. If it were a 2, there's no number to go in here. With this being 3 or 4, you'll see that the only digit it can be in this bulb is a 2. Let's not abandon this junction, though yet we traced it this direction. It will be useful to trace it this direction, in part because it's bound on the small end pretty well. This cell here coming down from a 5 can't be a 4, so it can be a 2 or a 3. This 2 or 3 has to get smaller. There's already 2 in the column, so we limit ourselves just to this 1. These 2 small digits filling this column and the 4 and 5 already here actually completely limit the digit in this spot to a 3. And we can trace this up in either direction, but what the next spot will sort of make progress is to see the 3 here eliminates 4 as a choice in that cell, and we're now just left with one option, 6. 6 has to get up here to an 8, so it's actually going to have to just be a linear increase, 6, 7, 8. This cell here has to be between 1 and 6, 2 and 5 limit it, so we can write 3, 4 here. You ask why I write lots of pairs in this puzzle. Well, I like pairs in general in Sudoku puzzles because it's the most useful kind of note. Notes like 4, 5, 7 aren't quite too helpful. In thermo puzzles, almost always the constraints work out that you'll find 2 thermometer cells in some row or column that give you the same pair. We just did that. We found 3, 4, 3, 4 limitations here, and that will eliminate options elsewhere. It actually gives us very quickly that 2. It also gives us this 5. We can take advantage of some other information. I guess now is a good time to start using a different kind of logic that comes up in Thermo-Puzzles all the time, but where can extreme numbers go in cells that are in the middle of thermometers? So digit 1 can't go in the middle of these shapes. Digit 2 can't go in the middle of these shapes. So these are placed equivalently in the high end. The digit 9 and the digit 8 can't sit in these cells. The 9 is for a different reason, but the 8s you should see can't go in those cells, and so the 9 has to sit here. The 8s have to sit here. We can just use that to cancel some of the grid. The next kind of spot we might want to make progress, just building off what we've read in the center, is filling out more of these numbers. We get this column complete except for the pair. Get a 5 into this cell, and this quickly feeds out to the junction around it, which can only be a 7, makes this an 8. We'll just trigger the pair and its consequences. So 8 gives us 8, 9, gives us another 9. In the spot, we actually have constrained this cell to be a 6. This is a 1, got a 3, 5 here, got a 3 up top, a 1 here, got 2, 4. Placing the 6 before we sort of move too far actually puts a constraint on this cell. It can't be a 6 or 7 anymore, so it's limited to being just a 5. Just following the thermometer shape for a little longer, you can actually fill out these columns. Get a 6, 4, 5 here. I see a pair as I'm writing this in. I'm not sure if it'll be very helpful to recognize, but it's always good when you're writing numbers to see if you have some potentially deducible information. 7 could come up to 8 or 9, but it's already in that space. This cell can't be 6, 8, or 9, so it's got just this option that lets us fill in the center. Let's take these digits and keep working with them. So we get a 7 over here, a 7 over here. That's all the 7s in the grid. We had the 6 coming here, and a 6 over here. That's all the 6s in the grid. This is now an easy column. 1 of 9. Working off 1 again, I get over to here. We can place the remaining ones while we're at it. This row is almost done. Here's the other 2. We're going to get a 2 up here. Don't know where yet. We're going to get a 3 in these cells. Let's look in this spot. This digit off the thermometer has to be larger than 6, can't be 7 or 9. So this is an 8. Gives us this 8. Gives us this 8. This 8. This area needs another 9. And another 9. That will force a 4, 5. Which will do the rest of these columns. The 4, 5 into the middle. This space also a 4, 5. It's now constrained to this option. The remaining 2, 3, and we're done. So it doesn't have to be as hard as a puzzle as it seems, but it actually has a very, very narrow path. At the start, it's tracing up in the grid to get this as a 9. That's then jumping over here to trace down in the grid from 8 into these spaces, ultimately finding a 2, a 1, a 3. This then works together to get this space going, and so on. But it's very cool for these junctions. The way we work into and out from the junctions all the time really is one of the highlights of, I think, this genre, that you can use some patterns that really have nice embedded logic unique to the puzzle. And so as a credit to Swaroop for the great entry. Too hard for the magazines we submit most of these Sudoku to, but perfect for the website. So glad to have the submission. Hope you learned something about solving these puzzles, and we'll see you again soon.